Hello Year 11 and welcome to our second video here for probability. In our first video we were looking at sample spaces as much as anything else, and today we're going to look at sample space graphs and tree diagrams. Okay, these help us to count how many favourable outcomes and how many possible outcomes, right, which is how we calculate probability. So here we go. Let's get my head out of the road there. Sample space graphs and tree diagrams. Sometimes we've got multiple stages. There's more than one sort of step. Right? I might take a die and throw it twice. That makes it a two-stage event. The sample space of a two-stage event, right? For two stages, we can use a table, or what we call a sample space graph. Okay, rows and columns. And here's an example to demonstrate how that works. I take a die, I throw it twice, and I multiply the numbers together. I want to know what's the probability that the product of those numbers is greater than 12, and also that the product is odd. So what I do is, actually I think my head's going to be in the problem right there. What we're going to do is draw up a table. Nope, I'm in the road there. I draw up a table. Now I have decided to make my columns my first throw, my rows my second throw. Okay, so these are the things that could happen. My first throw could be a 1, 2, 3, 4, 5 or a 6. My second throw could be a 1, 2, 3, 4, 5 or 6. So let's say the first one was a 1 and the second one was a 1, and that would mean that the product of those is 1. If I threw a 1 and a 2, the product is 2, and so on for, if the first die was 1, whatever the second die might be, these are all of the outcomes if the first throw was a 1. If the first throw was a 2, these are all of the possible outcomes, right? 2 combined with something on the second die, and so on until we have filled out that table. Now you'll see it has 6 rows and 6 columns, which gives us a sample space of 36. I have color-coded this a little bit. So the product is greater than 12. I found all the numbers there in that grid that were greater than 12, and I've highlighted them in that yellowy orange. And if we count them up, we'll see that there are 12 of them. So it's 12 out of 36. 12 out of 36 is 1/3. So there's a 1 in 3 chance when I roll the 2 dice and multiply the numbers together. There's a 1 in 3 chance that that product will be greater than 12. Oh no, I've missed one. Look, there's a 16 there. You have to fix that up. It's going to be 13 out of 36. Scrap that answer. Scribble it out. I can't do it right now. Just realised I can't count. Didn't know 16 is greater than 12. So there you go. Be a little careful there. It's not 1 over 3. It's not 12 over 36. It's 13 over 36. That won't simplify. What about the probability that the product is an odd number? Well, I've highlighted those in red, and hopefully I haven't missed any of these. And you can see there we have 9 out of our 36, and 9 over 36 is 1 over 4. So that was a two-stage experiment, right? We rolled 2 die, and so we used a table. That was good. However, sometimes we have more than 2, and unless we're going to use some sort of 3-dimensional or multi-dimensional table, we're going to need to come up with another method for looking at our sample space. So we can use a tree diagram. Okay, now tree diagrams have their limitations as well. They do allow us to do more than 2 stages, but they can get a little out of control if the number of outcomes keeps increasing. So with our tree diagram, we have a start point, and for every stage we generate a new set of branches on our tree. I'll show you how that looks. So here we have 2 bags containing some cards. The first bag has 3 cards, and one of those cards has an A, one has an O, one has a U. So visualize this. There's a bag with 3 cards in there, an A, an O, and a U. There's another bag that has 2 cards. It's an L and an M. I've got 2 bags, 5 cards altogether, 3 in one, 2 in the other. They've all got different letters. Now I'm going to create a 3-letter word by choosing at random one card from the first bag. So that's going to be an A, an O, or a U. Then one card from the second bag. So it'll be an L and an M. And then I'm going to choose one of the remaining cards from the first bag. So I won't be able to have A, L, A because I can't use the A twice. I can't have A, O, M because the second card, right, the second letter in my word is going to be an L or an M. Right. Take a moment to check out how this is going to work if you need. We're asked to list the sample space and then find the probability that the word is perhaps A-L-O. Let's see if I can get out of the road here. So, here's my tree diagram. There's my start point, and there are 3 different things that could happen at the beginning. Could be an A, an O, or a U. So you can see I have 3 branches coming from that start point. That's my first letter in my word. Now, the second letter, right, the second stage in this experiment is I need to choose a letter from the second bag. So if the first letter was A, I could choose an L or an M, so you can see it's branched off there. If the first letter was an O, again, it could be an L or an M, and so on with U. There's 2 letters of our word. I still need to choose the third one, and remember this is coming out of the first bag. Now, the first bag only has 2 cards left in it. So if the first card was an A, the last card can't be an A, only an O or a U. So O and U's branch off each of those previous sort of branch tips. And so on until we have finished our tree. And it's mostly finished, but what we really want at the end is a list of the outcomes. Right, so this is going to be our sample space really here at the end. What I do is I collect those letters along from the start to the tip of the final branch. So A-L-O is the first word. A-L-U along this way will be the second word. Then A-M-O, A-M-U, and so on until I have my sample space listed there at the end of the tree diagram. So, if we count them up, we'll see that we have 12 outcomes there. The probability that the word is ALO, well, the first word here is an ALO. Are there any other ALOs? No. So the probability is 1 out of 12. Now, the question doesn't end there. What about the probability that the letter O doesn't occur, that the letter O stays in the bag? Well, it's not this one, it is this one. So 1, and if you're in an exam, I'd probably highlight these or something. 1, 2, 3, 4. So there are 4 words that don't have an O in them. And 4 out of 12 is 1 over 3. Next up, that M and U don't both occur. So this means I could have M or I could have U. That's fine. I could have neither. That's fine as well. But I don't want a word that has M and U in it. So the first one is okay. The second is okay, and the third, but the fourth is a problem. So we're up to 3, 4, 5, 6, 7, 8. We fall over. So 8 of my 12 words don't have both M and U in them. And that simplifies to 2/3. Finally, here we go. How many of these words have the letters in alphabetical order? You check through them. But O and U both come after L and M. So if my first letter is A, right, that'll always come first. So all of these ones are good. So my first 4 are good. I definitely can't have A at the end. So this is no good. This is no good. And so on. In fact, it's only when A is at the beginning that the letters will be in alphabetical order. So, how many are there? Again, it's the first 4 in my list, 4 out of 12. There's a 1 in 3 chance that my word will end up in alphabetical order. So that's it for sample space and tree diagrams. Just to wrap it up, What did we learn here today? That two-stage experiments can be represented with a table, or what we call a sample space graph. And experiments with 3 or more stages, well, they're typically better represented with a tree diagram. Now, that's it for sample space and tree diagrams. If you've got any questions, please make sure that you ask me about them. And some of these ideas are a bit confusing, and sometimes I slip up and get it wrong, as I did at some stage during this video. Make sure you correct that too, please. Thank you. And just a little teaser, a preview. Coming up next, sets and Venn diagrams. Okay, thanks you, Year 11. See you next time.